In today's session, we will be discussing electron configuration. Many learners get nervous when they hear this term, and many of them find it difficult. So we have come up with this three-part video series which will not only help you to overcome your fear, but you will get a crystal clear picture of the entire concept. So let's begin. When you hear the term configuration, what comes in your mind? Some kind of arrangement, right? What do you mean by configuration? Configuration is a particular arrangement of a group of things. For example, the arrangement of books on the library shelves, or the arrangement of dish on the rack, or distribution of different spice jars in the kitchen cabinet. Similarly, the electrons are arranged in a particular manner in the atom. As you can look into the diagram, there is a particular arrangement here. So now let's define electron configuration. Electron configuration is distribution of electrons in an atom in a particular manner. For example, oxygen. Oxygen has 8 electrons and the configuration is 2 and 6. Another example is sodium. As you can see, it has 11 electrons. So the configuration is 2, 8, and 1. Chlorine is another example, which has 17 electrons, and the configuration is 2, 8, and 7. Since electrons are not located in the nucleus, they can be found anywhere outside it. Knowing where exactly an electron could be difficult. We cannot know exactly where the electron is at any given time, but the electrons are more likely to be in this specific area. Since the electrons are not located inside the nucleus, they can be found anywhere outside. It's very difficult to know exactly where the electrons are located at a given time, but we can find them here in this specific area, as you can see in the diagram. As you know, the positively charged protons inside the nucleus attracts the negatively charged electrons, as you can see. At the same time, the negatively charged electrons mutually repel each other, causing them to stay around the nucleus in a regular pattern. This results in geometric structures called orbital that surrounds the nucleus. According to the Austrian physicist Erwin Schrödinger, this area is called electron cloud. So how do we define electron configuration? Electron configuration is a simple way of writing down the location of the electrons. It's the distribution of electrons in the orbital of the energy level of an atom. Let's look at an example that you have already learned. This is a neon atom. As you know, neon has 10 electrons. So if we do the electronic configuration of neon, you know that it will be 2 and 8. The inner orbit will hold 2 electrons. This is 1 electron and 2 electrons. And the remaining, that will be 8 electrons, will be in the outer orbit. That's 1, 2, 3, 4, 5, 6, 7 and 8. Why is electron configuration so important? Because electron configuration shows the chemical behavior of an element. It helps in chemical bond formation, as you can see in this image. There is a bond formation between two atoms. It also helps to find out the number of valence electron of an atom. As you can see here, this is a sodium atom, and looking at this diagram, you can tell that the valence electron is 1 here. So it has 1 valence electron in its outermost shell. And it shows the reactivity of the elements, which depends on whether the valence shell is complete, like in neon. You can see the outermost shell is all filled, or incomplete, as in sodium. This is an incomplete valence shell. Why? Because there is only one electron in here. Takeaway from today's session. Electron configuration describes how electrons are distributed in its atomic orbitals. It's hard to find the exact location of the electrons, but it could be said that they are arranged around the nucleus of an atom in an area known as electron cloud.